3.5? Sorry, 7.
7.
Yes. Okay. Let's say we had 5, 7, 6, 8. So in that case, it would be 7 plus 6 by 2. That's 6.5. Okay. Now when we have a grouped data, so if discontinuous, you have to convert that into continuous. For mean, you may not, but for median, you have to. Once you have the continuous, for example, let's say something like this.
Yeah. I think 45, 50-ish.
Okay. Okay. So I think, yeah, we can pull this up to 90, 95. Definitely. In this 1 month. Okay. So we have to start with median. Let's say you're having ungrouped data. So for that, if you have the number of observations as odd, median would be n plus 1 by 2 th term. That would be your median. If your n is even, your m would be n by 2 th plus n by 2 plus 1th observation divided by 2. That would be your
Yeah.
median. Right? We can take an example. Let's say we have something like this. Uh, so since there are even number of terms, right? Right. So we'll use this thing. So definitely. Okay. Can you tell me mean, median, and mode? Out of these three, what all are unique for any data set?
As in?
Let's say you have a data set, you're calculating these three. What all of these three have to be unique? For example, there can only be one of each of it. For example, there can only be one mean for a data set, like that.
Yeah, there can only be one mean,
Okay, so this is
one
unique.
median.
What is median?
Median is only one, right?
It's the middlemost observation.
Yeah. Mode can be more than one, I think. Depends on the set.
Correct. Mode mode can be. So mode is what? Highest frequency, right? Highest
Yeah, because
occurrence.
if it's like 5, 5, 7, 7, then
Yeah, so mode are both. Yeah, correct. Okay, so this is unique. This is also unique, and this may not be unique. Okay. So here can you see how the median, if you try to calculate, that would be n is 4. So that would be second plus third term by 2. So that would be 3.5. Sorry, 7.
7.
Yes. Okay. Let's say we had 5, 7, 6, 8. So in that case, it would be 7 plus 6 by 2. That's 6.5. Okay. Now when we have a grouped data, so if discontinuous, you have to convert that into continuous. For mean, you may not, but for median, you have to. Once you have the continuous, for example, let's say something like this. Frequency is there, let's say 4, 5, 1. You'll calculate cumulative frequency. For this, it would be 4 only. For this, it would be this plus this. So 9. For this, it would be this plus this. So 10. Like that. So eventually, when you have all the cumulative frequencies, so this is what? Nothing but sigma fi only. This 10. Right? You'll calculate something called as n by 2, which is the frequency by 2. So that's 19 by 2. So that's 9.5. Now you'll see where is 9.5 appearing. See, 9 is in the cumulative frequency column. So 4 is still here, 9 is still here. 9.1 will definitely come in this. So this becomes your median class. You call this as median class. Right? Now your median would be whatever is the lower limit of the median class plus n by 2 minus whatever is the cumulative frequency of the preceding class. So that is 9 here. Okay, and into whatever is the class size. Okay,
Yeah.
upon
Sorry, I was
whatever
saying
is,
yes and yes, but then I was on mute.
okay, so into h, and here it comes frequency of the median class only. So if I have to, what is the frequency of the median class? That's 1, right? This is 1. Okay, so technically your formula becomes L plus n by 2 minus cumulative frequency of the preceding class upon f of median class into h. This is your formula. L is the lower limit of the what? Median class. So I'll write Ln here. Okay, this is the frequency of median class. Okay. N is what? Sigma fi. Now for mode, just a minute.
Yeah.
Can you hear me?
Yes, I can.
Okay. So I was saying for mode, let's say you have ungrouped. So that you can very well calculate what is the highest frequency, right? By just observation. When you have grouped, here also, if discontinuous, convert into continuous. So only for mean you may not convert. Otherwise, for median mode, you have to convert discontinuous to continuous. Let's say, okay, I'll just write the formula only. Here, what happens is your mode comes out to be L plus Fm minus Fp upon 2Fm minus Fp minus Fs into H. Okay, let me name. So L would be, what do you think L would be here?
Pardon?
Okay, I'll give you an example only. 0 to 10, let's say you have this sort of continuous.
L is the lower limit, right?
Yes, correct. Let's say you have Fi 5, 10, 3, 9. Okay, now you know mode is the highest number of times occurring observation, right? Can you see how naturally we would think that, oh, for this class, we are having 10 frequencies, right? So maybe the mode somehow lies in this class only, right? This can be an assumption. So we will consider this to be the modal class, right? So this becomes our modal class. Okay, once this middle becomes a modal class, definitely this 10 is what? That is your L M, right? Here I think I use small m. It should be, let's make that capital M because it's for median. Frequency of median class here also M, capital M. Okay. So Lm becomes your 10. Now what is your Fm? So that is the frequency of modal class, right? So that is what here? That is also 10 here. Now Fp is what? Frequency of the preceding class. That is what? 5, right? Fp is 5 here. Now Fs is what? Frequency of succeeding class. So that would be what? 3. H is what? Class size. That is what? 10, right? Class size is what? Upper limit minus lower limit. What is class mark that we use in mean? That is upper limit plus lower limit upon 2, right? Actually, see, you have something like, let's say this, or let's say 10 to 20. What would be the class mark of this, which we learned in mean? That would be the middle of this basically,
Mm-hmm.
right? So 15. So that's upper limit plus lower limit by 2. Correct. So all of this is clear to you, right? So all of this was mean, median, and all whatever. Now we have this mean deviation. So that's actually mean of deviation with respect to A. So you are deviating your values with respect to a particular value, and then you're calculating the mean, right? Let's say you have x1, x2 all the way till xn. You are deviating every value. So you'll have something like this, and we're taking the mod here. This is the mod. Why? Because we want somehow the positive values only. So let's say this x1 minus a, x2 minus a, like that.
Mm-hmm.
So your definitely your mean becomes this only. And if it is grouped, so you'll definitely write it like this would be for ungrouped. And if it is grouped, so it would be what? You will include frequency here then. See, for grouped and grouped, you don't have to learn separately. because technically whenever we have grouped data set, there's frequency in it. So that's why we multiply every observation with its frequency, number of times it is occurring. So it's not like how did this formula come from here, right? It's easy to understand. Okay. So I can write it like mean of deviation, mean deviation
Yeah.
with respect to mean. That would be what? Just replace A with mean. Correct. So this we can do, and after this, okay, let's take an example only. Let's say we have these observations, all the way till 200. We have to calculate mean deviation with respect to the mean. This is also another symbol for mean, right? Now, what is the mean of this? Can you tell me very quickly?
Can you hear me?
Yes.
Mean of 100 to 200, right?
Yes.
150.
Yes. Okay. So since the values are large, I mean, what we do for mean deviation is we technically are trying to shorten our observation, right? So we subtract 150 from each of these values. So we'll have minus 50, minus 49, then somewhere 0 will appear, then 1, 2, so on till 50, right? You just have to sum up these, right? How many numbers are there from 100 to 200? Okay, sorry. Yeah, how many numbers are there from 100 to 100? There are like 101 or what?
101. Yeah,
Okay.
101 inclusive.
Yes. So we just add these whatever values. So it's 0 nothing. So basically this is 50 into 50 1 by 2 into 2, because we take the mod, right, and divide by 1
Mm-hmm.
0. Okay, this is the answer.
Got it.
Now we have standard deviation and variance. So standard deviation is sigma, variance is the square of sigma. So variance is the square of standard deviation.
I did a question like the previous one, but it's basically 1, 3, 5, 7 until 101. So how would you do that?
1357 up till 101.
101. Yeah, so the
Okay,
mean is 51. And we have to find mean deviation.
mean is 51. Okay, yes. Mm, you have to find mean deviation. Okay. Yeah, so we just mean deviation with respect to mean would be just subtracting 51 from all these values. So
Many students practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.